everyone. We are Group 2 and our project title is Application of Derivative and Integration in Geoscience, a study of river flow in Malaysia. Rivers play a very important role in Malaysia, especially as sources of water, transportation and support for ecosystem and human activities. However, river flow can change rapidly, especially during heavy rainfall and monsoon seasons. In this project, we explored how mathematical concepts, specifically derivative and integration, can be used to better understand river flow behavior and its environmental impacts. We used real Malaysian river examples such as Sungai Pahang, Sungai Rajang, Sungai Kelantan, and Sungai Muar to connect mathematics with real-world geoscience problem. Through this study, we aim to show that mathematics is not only a theoretical subject but also a practical tool that helps explain natural processes around us.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Yuzaini Akmal, Metric Identification E25A 3560, and today I am going to talk about flooding risk at Sungai Pahang and how integration in mathematics is used in geoscience to understand flooding. In this presentation, I'll cover the background of Sungai Pahang flooding, why integration is used, the mathematical model, the calculation result, and finally the geoscience interpretation. First, the background. Sungai Pahang is very vulnerable to flooding, especially during the northeast monsoon. This is because of heavy rainfall, a large catchment area, and the gentle slope of the river. When the rainfall increases, the river discharge rise quickly and can overflow, causing flood that affect nearby settlements. You guys must be wondering why integration is used in this situation. Well, river discharge changes continuously over time, not a fixed value. So instead of looking at a discharge just at one moment, integration allows us to calculate the total volume of water flowing through the river over a specific time period. This gives us more accurate assessment of flood risk. And now for the mathematical model. As you guys can see, the river discharge is modeled as Qt equals 200 plus 20T, where Qt is discharge in cubic meters per hour and the T is time in hours. And for the calculation result, when we integrate Qt from 0 to 6 hours, we get a total water volume of 1560 cubic meters. This shows that a large amount of water accumulates in a short time during heavy rainfall. For the conclusion or the geoscience interpretation, I can see that a large cumulative water volume over a short period causes river level to rise significantly. This increases the risk of flooding, especially in low-lying areas along Sungai Pahang. By understanding this total discharge, authorities can improve flood mitigation planning and early warning system. In conclusion, flooding at Sungai Pahang mainly happens due to continuous heavy rainfall during the northeast monsoon, which causes the river discharge to increase over time. When a large amount of water flow into the river with a short period of time, the river level can rise quickly and overflow its banks. By using integration, we can calculate the total volume of water flowing through the river instead of just looking at the discharge at one moment. This helps us to understand flood risk more clearly and show why proper monitoring and flood management are important to reduce the impact on nearby communities. I think that's all from me. Thank you for watching.
Assalamualaikum and hi everyone. I am Ahmad Zulfaika bin Abdul Haris, and for my part, I will be discussing problem 2, which is focused on river erosion at Sungai Rajang, Sarawak. In geoscience, modeling how fast river flow change is vital to predicting soil stability and preventing landslide. Our mathematical model for the river discharge is Q of T equal to 180 plus 15T. To find the rate of change, we apply derivative. By differentiating this function, we get Q prime of T equal 15. This result tells us that the discharge is increasing at a constant rate of 15 cubic meter per second every hour. I verified this calculation and it is mathematical accurate. So what is the geoscience impact? A constant increase of 15 cubic meter per second square means the water is steadily gaining kinetic energy. This energy creates shear stress that scores the riverbank. In conclusion, for this problem, understanding this derivative allows us to predict when the erosion will reach a critical level, giving authorities time to reinforce the bank and protect our communities itself. So that's all from me. I pass to the next person. Thank you.
Hello everyone. For problem 3, I will be discussing sediment transport at Sungai Kelantan during the monsoon season. The discharge of Sungai Kelantan plays a major role in sediment transport, especially during periods of heavy rainfall. During the monsoon season, increased rainfall raises the river's flow rate, allowing it to carry more sediment downstream. This process significantly affects river geometry and increase flood risk due to sediment deposition and riverbed shallowing. In this study, the discharge rate of the river over a 5-hour peak rainfall period is modeled by the function where Q of T is the discharge in cubic meter per second and T is time in hours. To find the total volume of water, we use integration. We set up a definite integral from t equals to 0 to t equals to 5. After integrating, the antiderivative become 220 times t plus 9 times t square. Substituting the limits give a total discharge of 1325 cubic meter of water over the 5-hour period. This result represent the area under the curve, showing how integration converts a time-varying flow rate into a cumulative volume. From a geoscience perspective, this volume is significant. A larger volume of fast-moving water increases the river's capacity to transport sediment and its competence to carry larger particles such as sand and silt. When the river flow slow downstream, this sediment settle, causing siltation and reducing the river's ability to hold water. Therefore, this calculation is essential for flood forecasting, river management, and engineering planning. By using calculus to quantify water discharge, geoscientists and hydrologists can better predict sediment build-up and design effective flood mitigation strategies in Kelantan. Thank you.
Assalamualaikum and a very good morning. My name is Muhammad Lemah Hakim bin Khairul Azhar, matrix number E25A3562. Today, we explore how heavy metal affect river discharge and water quality using Sungai Muar in Malaysia as an example. To begin with, when it rains heavily, water flows over urban areas, farms and roads, picking up sediment, fertilizer and other pollutants before entering the river. River discharge is the amount of water flowing in the river, measured in cubic meter per hour. During storms, discharge increases because more runoff enters the river. Scientists model discharge over time. For Sungai Muar, we use this equation, which is Q of T equals 160 plus 30T, where T is time in hours. We use derivative to find how fast discharge is changing. Differentiative, the equation gives us dq over dt equals to 30, meaning the discharge increased by 30 cubic meter per hour, which is every hour. A rapid increase in discharge can temporarily dilute polluted at a single point, but overall, more polluted water is transported downstream. This means sediments, nutrients contaminated can travel further and affecting aquatic life, water treatment, plants, and communities downstream. By looking not at how much water is in the river, but how fast it's rising, scientists can better predict When was water quality risk at its highest? That's all for me. Thank you for watching. Understanding the river discharge help us care for our environment. Bye.
In conclusion, this project helped us to understand the importance of derivative in geoscience, especially in the study of river flow. Derivative allow us to measure the rate of change of river discharge over time, which is very important during heavy rainfall events. Instead of knowing only how much water is in a river, derivatives show us how fast the river is changing, which can indicate sudden environmental risks. Through Malaysian case studies, we learned that a rapid increase in river discharge can lead to serious geoscience problems such as riverbank erosion, increased sediment movement, and changes in water quality. These changes can happen in a short time and may affect nearby communities, ecosystem, and river stability. By applying the derivative, we are able to better understand how rivers respond to rainfall and human activities. This knowledge is important for early warning system, river management, and environmental protection. Overall, this project showed us that derivatives are not just mathematical formulas, but powerful tools that help explain real environmental processes and support more responsible decision making. Thank you.